Welcome to this session on vector geometry. Today, we are going to master how to solve IGCSE exam-style questions involving vectors in shapes. In this lesson, we have three main objectives. First, we will express unknown vectors in terms of given basis vectors. Second, we will use ratios to find points along a line segment. And finally, we will determine ratios from given vector equations. By the end of this video, you will be able to navigate through complex diagrams by breaking them down into simple vector paths. We will work through 5 specific examples ranging from basic triangles to parallelograms. Let's dive into our first problem. In this first example, we are given a triangle OPQ. Our goal is to find the vector OS in terms of A and B. We are told that S divides the line PQ in the ratio 4:5. To get from O to S, we need to find a path. A simple one is to go from O to P, and then from P to S. First, let's find the full vector PQ. To go from P to Q, we go backwards along A and forwards along B. Now, because the ratio PS to SQ is 4:5, the line is split into 9 equal parts in total. PS is 4/9 of the way along PQ. Finally, we find OS by adding our vectors, OP plus PS. Expanding the brackets, we get a minus 4/9 A plus 4/9 B. Simplified, this gives us 5/9 A plus 4/9 B. For our second example, we have triangle ORT. We need to find the position vector of x. Remember, the position vector of a point is just the vector starting from the origin O to that point, so we are looking for vector OX. We are given the ratio Tx to xr is 3:2. Let's find the path for the full side TR first. To get from T to R, we go against the arrow of T and with the arrow of R. Since the ratio is 3:2, the total number of parts is 5. X is 3/5 of the way along the line from T. Now, let's construct the path for OX. We can go from O to T, and then from T to X. Substituting our expressions, let's expand and group the terms together. 1 whole to minus 3/5 T leaves us with 2/5 T. This is our final answer in its simplest form. Notice how the position vector is a weighted average of the two vectors defining the triangle's sides. Now, let's look at a parallelogram, OABC. This introduces a new property. Opposite sides of a parallelogram are equal and parallel. We are told that OA equals P and OC equals Q. In a parallelogram, this means CB is also P and AB is also Q. We need to find the vector OE, where E is on AB, such that the ratio AE to EB is 3:1. Since AB is the same as OC, we know the vector AB equals Q. The ratio 3:1 means the segment is split into 4 parts. AE represents 3 of those 4 parts. To find OE, we follow the path from O to A and then from A to E. Substituting our values in, OE equals P plus 3/4 Q. This is already in its simplest form. When working with parallelograms, always remember to translate the vectors from the base sides to the opposite sides to help you find your path. In our fourth example, we have a slightly more complex triangle, OAB. We are given that C is the midpoint of OA, and the vector OC is M. This means that the vector CA is also M, because they are the same length and direction. Consequently, the whole vector OA is 2M. We are also given that the vector CB is N. Our goal is to find the position vector of E, which is the vector OE. The ratio provided is AE to EB equals 4:5. First, let's find the vector for the side AB. We can go from A to C, then C to B. Since going from A to C is against the direction of M, we have AB equals negative M plus N. The ratio 4:5 tells us there are 9 parts in total. AE is 4/9 of the vector AB. Now, to find the position vector OE, we take the path O to A, then A to E. Substituting the values we found, OE equals 2M plus 4/9 times the quantity negative M plus N. Let's expand the brackets. To simplify, think of 2 as 18/9. 18/9 minus 4/9 gives us 14/9. That is the position vector of E in its simplest form. Our final example flips the script. Instead of using a ratio to find a vector, we are given the vector equation and must calculate the ratio. Triangle OAB. Vector OA is x, vector OB is y. Point D lies on the line segment AB. We are given that OD equals 3/7 x plus 4/7 y. We need to calculate the ratio of the lengths AD to DB. To do this, let's look at the vector AD. We can find it using the path O to D minus O to A. Substituting our values, AD equals 3/7 x plus 4/7 y minus x. This simplifies to negative 4/7 x plus 4/7 y, or 4/7 times the quantity y minus x. Now let's look at the full vector AB. It is OB minus OA, which is y minus x. Look at the relationship between AD and AB. AD is exactly 4/7 of the total length of AB. If AD takes up 4 parts out of a total of 7 parts along the line, how many parts are left for DB? It is 3/7 of AB. So if AD is 4 parts and DB is 3 parts, the ratio is simply 4 to 3. Let's recap what we've learned. We expressed OS, OX, and OE by following paths. We used ratios to find fractions of vectors. And we calculated a ratio by comparing a segment to the whole line. Great work today. You've seen how to tackle various vector geometry problems by breaking paths down into known components. Keep practicing these pathfinding steps and you'll be well prepared for your exams.